Welcome back to the Explainer. Okay, let's dive right into this, because today we are tackling a massive milestone in any system architect's career. We're looking directly at the Day 12 system design curriculum, and we are embarking on a serious scaling journey. If you've been following along with system design principles, making something work for one user, super easy. A dozen users? Totally fine. But today, we're talking about what happens when your app goes absolutely viral, and you have to completely rip up and rethink your data foundation. 100 million. Just let the sheer weight of that number sink in for a second. That is the massive stake of today's practice problem, straight from our source material, designing a database for 100 million users. I mean, imagine the sheer volume of data, the relentless flood of queries, the constant read and write operations happening every single millisecond. To support this sheer scale, a normal, out-of-the-box, single-server setup doesn't just slow down under this pressure. It literally melts. It's inevitable. You cannot just brute force your way through 100 million users by buying a bigger hard drive or a slightly faster processor. No way! You need to structurally change how your data is stored and retrieved. To survive this, we have to engineer an absolute masterpiece. So here's our architectural blueprint and survival guide for today. First, the 100 million user challenge. Second, vertical versus horizontal partitioning. Third, scaling up with sharding. Fourth, mastering consistent hashing. And finally, avoiding hot partitions. Section 1, the 100 million user challenge, the ultimate scaling test. Section 2, vertical versus horizontal partitioning, the basic fix.
Step into my office for a second. Let's pretend I'm your senior lead engineer and you're a junior dev taking on your very first massive scaling ticket. Our very first line of defense to break down this insane data load is partitioning. We've got this monolithic database that is just way too big, so we have to split it up. But how we split it? Well, that's the million-dollar question. Let's look at a stark contrast between our two primary options here. On one hand, we've got horizontal partitioning. This is dividing your data by splitting the rows. Imagine a massive spreadsheet of our 100 million users. Horizontal partitioning means taking the first 50 million rows, putting them in one place, and taking the next 50 million and putting them somewhere else. The structure of the data is exactly the same, there's just less of it in one spot. On the flip side, we have vertical partitioning. This is dividing your data by splitting the columns, or the features. Returning to that spreadsheet analogy, maybe every user has a simple username and password, right? But they also have a massive column for a high-res profile picture or a really long bio. Vertical partitioning means slicing that spreadsheet right down the middle vertically. You put the lightweight login credentials in one super fast, heavily accessed database, and you tuck those heavy, less frequently accessed profile pictures into a completely separate one. Both are absolute must-have tools for a system designer, depending on the specific bottleneck you're facing.
Section 3, scaling up with sharding, the next level. Okay, so we've partitioned our data, we're organized, but here's the reality check. We still have 100 million users. Eventually, even perfectly partitioned data is going to totally outgrow a single physical machine. We absolutely need to level up our strategy to handle the sheer volume of our target user base. Enter sharding. Sharding is the next evolution of partitioning. It's used as the ultimate scale technique to break down massive data loads. You can think of it as a powerful new tool in your architect's toolkit. If horizontal partitioning is splitting the rows of your database, sharding is taking those split rows and physically distributing them across multiple different independent servers, which we call shards. So instead of one giant server just sweating under the weight of 100 million users, you now have, say, 10 separate servers, each comfortably managing 10 million users. They don't share memory, they don't share storage, they are completely independent. This allows your op to scale almost infinitely. You just keep adding more shards as your user base grows. But you know how it goes in system design? Solving one problem usually introduces a brand new one. Section 4, mastering consistent hashing, traffic control. Because now I have to ask you a really important question. If you've split your 100 million users across 10 different physical servers, how in the world do you plan to route all that incoming traffic? Like when user number 42 million logs in, how does the system instantly know which specific shard holds their data? The answer? Consistent hashing. This is the essential mechanism for routing 100 million users smoothly across new shards. It's basically our vital traffic controller. Now, if you just used a simple, basic mathematical hash to assign users to servers, what happens when one of those servers crashes? Or when you need to add an 11th server to handle a huge spike in growth? Well, without consistent hashing, nearly every single user would get rerouted to a new server all at once. That would completely overwhelm your newly sharded system and cause a catastrophic crash. Consistent hashing brilliantly maps both the users and the servers onto a conceptual ring. This means that if a server is added or removed, only a really small, manageable fraction of your users actually needs to be relocated. It keeps the traffic flowing smoothly and, crucially, keeps the system from being brought to its knees during a massive scaling event.
Section 5. Avoiding hot partitions, the pitfall.
All right, so you've got your partitions, you have your distributed shards, and you have your consistent hashing routing traffic perfectly. Sounds great, right? But I need to warn you about the final villain that can sneak in and crash your beautifully designed system, the hot partition. A hot partition is a system-crashing danger and the final threat to a scaled architecture. The crucial point you have to remember is this: what happens if your data is perfectly distributed, but user behavior isn't? Imagine a massive celebrity joins your platform, and they happen to get assigned to shard number 3. Suddenly, 50 million of your users all try to view that celebrity's profile at the exact same second. It literally does not matter that your database is spread across 10 servers, because 99% of the traffic is all slamming into shard number 3 simultaneously. That shard overheats, it crashes, and it takes a huge chunk of your system down right along with it. A hot partition is a major threat that requires really careful, deliberate design to avoid. Often, you're going to need to add specific caching layers or further randomize the data distribution for those highly active entities. You must design not just for data size, but for data velocity and real-world user behavior.
So let's bring this all together into our complete survival guide. This is your step-by-step blueprint for approaching this massive practice problem. Step 1. Partition. Look at your data logically and decide whether you need to split rows horizontally or split columns vertically just to make it manageable. Step 2. Shard. Take that horizontal data and physically distribute it across multiple independent machines to achieve true scale. Step 3. Hash. Implement consistent hashing to act as an intelligent traffic cop. It routes requests safely and ensures your system can dynamically adapt when servers go down or new ones get added, all while keeping a very vigilant eye out for those deadly hot partitions.
Which brings us to the final thought for today's explainer. You've reviewed the source material, you've learned the ins and outs of horizontal and vertical partitioning, sharding, consistent hashing, and the danger of hot partitions. Your architectural blueprint is complete. The foundation is officially laid. So I leave you with this provocative question. Your system is designed, but can it survive 100 million users? Take these concepts, go apply them to your own practice problems, and find out for sure. Thanks so much for joining me on the scaling journey, and keep building.